Hey scholars, I hope y'all are doing well today. We're going to change gears a little bit and look in the coordinate plane for our lesson today, and we're going to discuss how to find the midpoint and the length of a segment in the coordinate plane. So pay close attention and take great notes. Let's get going. So let's start by answering this question. We want to find the coordinates of the midpoint of the segment. Now remember, the midpoint of a segment is right in the middle, right? It divides the segment into two congruent parts, or we'd say it bisects it. So that point right in the middle, well, it's hard to tell where exactly it's going to be. I can kind of guess, but maybe finding the exact coordinates could be a little tough. So let's think about how we might solve this. If you're trying to find your test average, like let's say you made a 90 on a test and you made a 74 on a test, and that 74 you're like, that's not a great grade, I wonder what my average is like. What you would do is take the 90 and 74 and add them together, and you divide that by 2. Well, you get 164 divided by 2, which would give you 82. So that's the average, that's the number right in the middle of those two scores. So the same thing works when you're trying to find the midpoint. What you're going to do is try to find the average of the x value and the average of the y value. So let's see. So our midpoint, I'll say it's m, is going to be the average of the x values. So what I'm going to do is say -2 plus 4, then I'm going to divide that by 2. And the y value, the average of the y values, is -1 plus 2, and we can divide that by 2. So the average of the x values and the average of the y values. That'll give me my x and y coordinate of the midpoint. So midpoint is -2 plus 4 is 2. 2 divided by 2 is 1. -1 plus 2 is 1. 1 divided by 2 is 0.5, or you can just leave it as 1 over 2, 1/2. There's the coordinates of the midpoint. Now, we can see where this falls on the graph. 1 to the right, up 1/2, and there's our midpoint. Now I prefer to think of finding the midpoint as finding the average of the x values and the average of the y values of the endpoints. But we also have a formula we can use, and I know some of y'all like to use formulas, so you can memorize this. The midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And here you see a worked example. Work that same problem from earlier, just using the midpoint formula. So we'll say the midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So what we need to do before we move forward is, it would help us to label, figure out what x1 and x2 and y1 and y2 are. Well, I'm going to say that -2 is x1, and if -2 is x1, then the y value next to it has to be y1. And then that would make the coordinates of D x2 and y2. So we're finding the average of the x values and the average of the y values. This is just a formula expressing that. So -2, I'm going to substitute at this point, -2 plus 4 divided by 2, and -1 plus 2 divided by 2. Does this look familiar? The midpoint equals -2 plus 4 divided by 2. Well, that gives us 1. And then -1 plus 2 is 1 divided by 2 is 1/2. The same answer we got earlier. Alright, so that's how we use the midpoint formula. So now let's think for a second. How can we find the length of CD? We want to find how long it is. But it's not vertical, straight up and down, and it's not horizontal, going left to right, to where we can easily count the units to see how long that segment is. But here's a trick. This slanted segment looks like the hypotenuse of a triangle, a right triangle. So what we can do is go horizontally from this point till we get to that point, and then we can go vertically up to it, and now we have a triangle. Well, we can count the units now. 1, 2, 3, 4, 5, 6. This leg of that right triangle is 6 units long. And then 1, 2, 3. This leg, 1, 2, 3 units. Alright, now what can we use here to find the length of the hypotenuse? Oh, that's right, we can use the Pythagorean theorem. So what I'll say, I'm not going to worry about the u here just yet. I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. And I can just substitute in. I'll say a squared is 6 squared. I'm saying a is 6. So 6 squared. And b is 3. Now I could have said a is 3 and b is 6. But it doesn't matter when you're dealing with the legs. They can be a or b. Equals c squared, the hypotenuse. So 6 squared is 36, plus 3 squared is 9, equals c squared. We get 45 equals c squared. And then we're gonna use a phrase that I've been using for quite a while. We want to get c by itself, so we are going to square root that junt. I want you to say it with me. Square root that junt. The square root of c squared is c, and then we're taking the square root of 45. So check this out. The square root of 45, you can break it down as the square root of 9 times 5, and we can simplify that. The square root of 9 is 3, but we can't take the square root of 5. So that's as simple as that radical can go. So 3 times the square root of 5 units. Or you could just write u for units. That's how long that segment is. Now another way to find the length of a segment is to use this thing called the distance formula. The distance formula is actually derived from the Pythagorean theorem. And I could show you in class how that's done if you're interested. But here's the distance formula. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is a formula that you may want to have memorized. If you're just given 2 points and no picture, it's a lot harder to find the distance. So you can use the Pythagorean theorem to help you out. So let's try this. I'm going to use the Pythagorean theorem. And remember, we're dealing with x1 and x2 and y1 and y2. Let's label those points. x1, y1, x2, y2. Alright, so the distance is the square root of x2, which is 4, minus negative 2 squared, plus y2, which is 2, minus negative 1. So we get the distance equals 4 minus negative 2, which is 6 squared, plus 2 minus negative 1 is 3. That's 2 plus 1, right? 3 squared. So we get d equals the square root of 36 plus 9, which equals the square root of 45, which, like we said earlier, equals 3 square root of 5 units. Alright, so we got the same answer using the distance formula as we did using the Pythagorean theorem earlier. It's crazy, right? So I hope that lesson was helpful for you. In our next class, we'll have some problems where you're not given a picture, you can't see the coordinate plane or the segment in it. You're just given 2 points, and you need to find the midpoint and the distance between them. So make sure you know those formulas well, or at least the methods for how to do them, and come to class with questions and prepared to work. Good work. Thank you, collegiate scholars. Also, just a heads up, you're going to have a test the second class of next week, okay? So make sure you're studying, you're feeling good about all the material that we've been covering so far. Start studying now. I'll see you in class.